Hello guys, welcome back to my channel. You're watching the second part of the series, What is Science, Why is Science? I'll cover topics like matters, antimatters, dark matters, parallel universe in this video. So watch this video to the end. Okay guys, our first topic is, guess what? Black hole. To describe what black hole is, we need to know about the birth of black hole. A star is powered by nuclear fusion reaction, where two hydrogen atoms react creating a free neutron and a helium atom. This reaction releases massive amount of energy which makes a star glow. As a star lasts some billion years, it needs an unimaginable amount of nuclear fuel. When a star runs out its fuel, it turns red. Then its high gravitational force starts pulling everything inside the star, and the dead star becomes to shrink. Then there comes a moment when the gravitational force of the star compresses everything of itself with such a high density that its escape velocity becomes equal to the speed of light. That's when a black hole is created. Black hole is defined as when the escape velocity of any celestial body reaches the speed of light, it turns into a black hole. According to this definition, even Earth can turn into a black hole. The escape velocity is inversely proportional to the square root of the radius of the body, and directly proportional to the square root of the mass. So the denser we make a body, the higher escape velocity we need to overcome its gravitational field. Escape velocity also depends upon the height from which we project anything. As we gain altitude, the gravity weakens, and so the escape velocity decreases. The most discussed part of a black hole is its event horizon. The structure of a black hole can be temporarily compared to a cone. Its space keeps decreasing as you go deeper into it. The circular base of the cone is the entrance of the black hole, where the tip point is the end. This end point is called event horizon. In the event horizon, the escape velocity is highest, the speed of light, as that's the place where gravity is strongest. The escape velocity is speed of light. So light become bounded in event horizon. We can see objects because they reflect lights. But black hole does not reflect any kind of lights or waves, because its high gravitational force pulls everything inside itself. For this reason, black hole is invisible. This isn't the end of the story. Modern physics says that if anything travels very close, or with, or faster than the speed of light, time gets affected for that object. For first case, time slows down. For second case, time stops. For third case, time moves backwards. Also, a very heavy object slows down the time for a finite distance, which can be observed near pyramids if seen from very far. By relating these two statements with black hole, we get that very high mass of black hole slows down the time near itself. And in the event horizon, time stops. For some cases, time moves backwards. I told in my last video that black hole has an important role to play in Big Bang theory. That's the whole reason why the world is researching on it. Black hole swallows everything near it. Its high gravity causes a high rotation, and that rotation can affect a whole galaxy. Just like our Milky Way galaxy is being affected by a supermassive black hole Sagittarius A. Also during the Big Crunch session, black holes are necessary to shrink the universe. And at the end moment, there will be only one black hole, which will have the whole universe compressed inside itself. This black hole will again cause Big Bang due to instability, and the cycle will continue. So guys, our next topic is matters vs antimatters. This story starts right after the creation of quarks after Big Bang. Quarks are charged particles. A positive quark has a positive charge of 2/3 of a proton, and a negative quark has a negative charge of 1/3 of an electron. There are also some anti-quarks having exact same amount of charges but in opposite sign, which means positive anti-quarks has 1/3 charge of a proton, and negative anti-quarks has 2/3 charge of an electron. One important point to mention here, that this charge composition is calculated in the basis of matter particles. For antimatter particles, positive charges discussed here will considered as negative charge, and negative charge will considered as positive charge. Anyways, the huge explosion or Big Bang released a massive amount of energy, and some of those energy converted into mass. Sir Albert Einstein proposed the well-known formula, A equals mc squared, which means energy can be converted into mass. Exactly that happened after Big Bang. Energy converted into mass, but 50% of that mass is matter or quarks at the beginning. and 50% is antimatter or antiquarks at the beginning. Different composition of quarks created electron, proton, and neutron, simply known as matter particles, where antiquarks created anti-electron or positron, antiproton and antineutron, simply known as antimatter particles. Those matter particles created matter, and antimatter particles created antimatter. Now a common question arrives that where are antimatters? The answer is, we still don't know. Then what are the purpose behind all these research? Well, let's see. The relationship between matter and antimatter particles are not quite good. If a matter particle touches its corresponding antimatter particle, then a large amount of energy releases, and they both disappear. So, we can see here that mass completely converted into energy, which proves that Einstein was right with his formula A equals mc squared. So, if we convert 1 kilogram of mass, 500 grams of matter and 500 grams of antimatter, into energy, then we will receive 9 multiplied by 10 to the power 16 joule energy. To understand this amount, let's take hydrogen bombs as an example. Destructive power of a hydrogen bomb is calculated in gigajoule, and giga means 90. But the energy released after collision of 500 grams of each matter and antimatter has 16 This energy is enough to blow up the moon. But if we can control that energy, and if we can reserve it, then we don't have to worry about future energy crisis or fuel crisis. Also, we can use that energy as rocket fuels. Photonic propulsion has its limitations. It can't propel heavy objects. But if we can control the amount of matters and antimatters colliding, and can direct the energy, though we can't direct gamma rays, we can reach 30% of speed of light. This concept is under development, and named as antimatter propulsion. It's a common misconception that if we don't know where is antimatter, then we can't use it for mankind. But this is not true. Scientists successfully created antimatter in lab, and they are researching on positron to understand antimatters. Scientists also designed a special reservoir for antimatter particles as their interaction with matter is very dangerous. Also, there is no need to worry about any kind of accidents. Because if we use all the antimatter scientists have, we can hardly heat a cup of tea. Well then, our next topic is dark matter. The visible universe, or on which we are currently researching, is just the 5% of the 100% of the whole universe. Among the rest 95%, 27% is dark matter and 68% is dark energy. Let me tell you the story behind the discovery of dark matter. Swiss-American astronomer Fritz Zwicky observed something in 1933. Distance between two celestial bodies, which are close to each other, is increasing. If we assume that it's happening because of effective gravity, then we can't describe the next statement. Distance between two celestial bodies, which are very far from each other, is increasing too, and with the same rate as previous. Gravitational field weakens as distance increases. So this phenomenon isn't because of gravity. It appeared that some invisible force or particle is responsible for this, which he named as dark matter. But after publication of his research papers, other scientists rejected this result, saying this is a calculation mistake. So dark matter was still in darkness. Later, scientists who were researching on some of the clusters, and their results were the same as Zwicky's. They calculated the whole stuff twice, but the result was the same. Finally, scientists agreed with Fritz Zwicky and dark matter was discovered. If we talk about the characteristics of dark matter, we'll certainly miss 95% of the major points. But still, we'll try to figure out what this dark matter is. 1. Dark matter has very low mass and density. We can hardly trace it by tracking Higgs field. But the scientists are trying hard to trace dark matter by tracking the Higgs field, because that's the only known option. Fermilab and Large Hadron Collider will be used to conduct this huge experiment. 2. Dark matter does not reflect or refract light or waves, and does not interact with matter or antimatter particles. Also, dark energy waves does not reflected or refracted by any known material. The waves will just pass through any obstacles. This is why dark matter is totally invisible. 3. We don't know where exactly we can find dark matters. They are controlling the expansion of universe, which is faster than the speed of light. That's why radius of universe is greater than the age of universe. These are all we know about dark matters. If you think why should we spend our valuable times behind such a thing which is impossible to find, then it's not your fault. dark matters are discovered. But unlike antimatters, we are unable to create it artificially. And as we know that from the beginning of universe, dark matters and dark energy is controlling the whole system and cycles. So we must study it to expose all the mysteries of nature. Our next topic is parallel universe. Yes, parallel universe is an important topic to discuss. This theory was developed from the conclusions of quantum physics. We'll discuss about quantum physics later. But the conclusion which triggered the theory of parallel universe is, a particle can be at two different locations, or coordinates, at the same time. Scientists developed this conclusion to a new theory, and proposed an existence of another universe, where the exact same particles of this universe are existing. That universe was named as parallel universe, and by some hypothetical research works, they came to know that time moves backwards in that universe. We always talk about universe, but long time ago, we saw a possibility of multiverse. This possibly indicated another universe just like ours, or a group of pairs of universes, in which the paired universes are alike. Yes, this sounds exactly like Dragon Ball Super. This is the concept of parallel universe. NASA recently approved the theory of multiverse, which means parallel universe can be true. But if we assume that parallel universe theory or multiverse theory is true, then we have to add some new informations in the theory of beginning of universe or multiverse. The first information is about the Big Bang. According to this theory, one explosion can create only one universe, which means there was more than one point where Big Bang occurred. If there are more than one Big Bang, then there must be more than one cycle of Big Bang, Big Crunch ongoing right now. I said that during Big Crunch session, only one black hole remains, which may not be true if multiverse is true. If there are multiple universes, then there must be some unknown space in which they are existing. Primarily, parallel universe theory or multiverse theory may not be seen that important, but the way of our research and development are highly depends on these theories. And that ends our current session. In my next and last video, I'll cover gravity, illusion of time, and some of the most discussed questions on internet. I hope you enjoyed this video. Please like this video, subscribe our channel and do comments if you have any questions. Thanks for watching.